Hello, we are doing a PowerPoint presentation on node counting smart piggy bank, and this project is of engineering exploration course, and we are from T01, and its members are NV Naganan, Rushali Kittur, and Sanjana P. Tiligal, and we are doing this project under the guidance of Sandeep R. Kurudavade. Okay, now let's see what our project's problem definition is. Okay, as you can see in PPT, we have a problem stating that design a node counting piggy bank which can do accurate and even automated counting of nodes, which can save time, and even the machine is lightweight, which is attractive, and it's also user friendly in nature. Okay, so like how can we make it user friendly? So we can keep some constraints like the dimension that like 25 centimeter in length and should not exceed 25 centimeter in breadth, 30 centimeter in height, and even the budget should not exceed more than 2000 rupees, so that it becomes more user friendly. And even to collect the amount after the counting, lockup system at the side of the machine, it should be a user friendly, so whenever the user needs, he can stop it and start it. And even the machine should display the total number of nodes and the amount we have put in, so that it doesn't create any confusion in the mind of the user. And it's a general thing, we should put a big storage for the amount. So this is the problem definition. So for this problem definition, there's a we have made a function tree to solve this problem, and we have clustered this problem into 5 different parts. Okay, let's go one by one. At first, there's a node handling. In node handling, there should be a provision for the machines to take nodes, so that it can take nodes and then detect. Next, storing of nodes should be there at the bottom. Next, third one by one taking of the nodes, so that the machine should not be crashed in between the nodes. And at last, there should be a provision for removing of the collected nodes. As I said in the problem definition, there should be a separate storage for the collected nodes. The next is the display system. In the display system, there should be the total amount of nodes collected and the total amount collected, so that there should be a synchronization between the amounts and the nodes. Third thing is a base stand, which is like there should be a platform for the machine to stand, so that if there is something like water fallen near the floor or something by the users, so the machine should not be harmed, so that there should be a base stand. And the fourth one is notification system. In this, the machine should notify the user when the storage almost filled, so that the user takes some of the nodes from the storage and makes some space to put the nodes again. And at last, the working mechanism, like how it works. uh, at first, when the sensors detect the nodes, the DC motor should be on, and after the process, the DC motor should come to the off state. After the node passing from the DC motor, there should be the color detector, so it can detect the color and we can come to know which node it is. After the node detection, it should directly go into storage slot. So these are the three mechanisms should be done. Now let's see what are the subsystems identified. The first is node inserting system, next detection of node, next is the storing of node. So these are the three primary steps we have taken for the subsystems. So after all these primary things and solving the problem, we have got some ideas on how our machine should look like, and we have generated some three drawings, or you can say blueprints, of our node counting piggy bank machine, which you can see in the PPT. So these are the best three designs what we got, and after analyzing the gains and losses of all the three designs, we concluded that the third design was the best, and it was like having all the constraints and statements of problem definition. So we choose this for that reason. So by this we have completed a part of the solution of the problem. So here ends the pen and paper work. Now let's watch this video. So for making this prototype, we have made what we have done on virtual implementation. So at first we have done a 3D modeling of the machine. You can use of button, rods, gears, the side and upper walls to cover the machine, and a display system, trays, and the 21st second of the video. In the upper photo, you can clearly see the storage of the nodes and the middle part where we keep the Arduino and other electronic things and the upper plate. And later you can see the assembled prototype from all the different angles and different sides. Makes our and after this we have made a circuit diagram which prototypes to run smooth and efficiently. So for this we have to write a program, and next there is a flow chart of our program, how it to be designed. And in flow chart, when we give the power to the prototype, the IR sensor we detects the object, that is node, and after detecting it, the DC motor runs and it takes some part of the node inside it, so that the sensor color sensor detects the node. If the node is detected as red, data stored is 20. It is blue, then the data stored is 50, and if it is green, it stores as 500. Again the DC motor runs so that the node goes completely inside the storage, and then it stops. This is the main part of the program. And at the side, this IR sensor is placed in the storage, so that if the storage is full, then it blinks so that the user comes to know that the storage is full. So this is the idea of the program and the flow chart. After this, you can see the bill of materials required for the entire system. We should, like, it has everything like part name, specification, material which is made up of, quantity required, if any fabrication required, everything. And we have written the different things we required for this prototype. And next you can see motor sizing and battery sizing of the entire system, and it is of like DC motor, how much it capacity of battery use, and like what is the maximum current consumed by the DC motor, etc. things. And next we can see the main thing, like how the prototype works, the function specifications. Like as I mentioned in the flowcharts itself, this when the note is inserted, IR sensor detects it, and the DC motor should turn anti-clockwise. At the end of the DC motor, there should be a gear which is connected to the another gear which has rod in it, so that the other rod will turn clockwise. So when we insert a note, it goes inside. So like this we can insert a note, and then later color sensor detects the color and sends data to the Arduino, and then the Arduino reads the data and it sends to the display system. This again the DC motor starts rotating so that the node goes completely inside the prototype and it directly goes to the storage. At the end, if the storage is completely filled, the air sensor detect any object or obstacle, then it blinks a LED light so that the user will come to know that the storage is full. And now let us see the simulation of this model, like how it works. So it's in a form of video, and at first we can see the entire program. Sensor detects the node, and after detecting it, when the node goes inside, then color sensor starts working, and the value as 500, and now that's invalid. So you can see we are given some inputs. The inputs given in the program is completely working fine. Thank you for watching this.